Hi, this question is question number 41 from chapter 27, and we have this figure wherein we are seeing there are two batteries and then we have three resistors R1, R2, R3, and the question has given all the values. So we have R1, R3 resistor of 5 ohm, R2 of 2 ohm, E2 of 1 volt, E1 of 3 volts, and R1 of 4 ohm. So basic logic says that current would be from the battery which has higher EMF. So E1 probably would be the supplier of the current. So we have assumed that there is a current I which goes into R1, and then we get part of that I1 into the second loop, and obviously I minus I1 comes to resistor R3. So these are the three currents, and we have used Kirchhoff's junction law for this. So currents incoming would be equal to currents outgoing. So now we will write Kirchhoff's loop equations for these two loops, loop 1 and loop 2. So we are going to write clockwise in loop 1. So this is 3 minus 4i minus 5 I minus I1 is equal to 0. So the total potential drop in the loop is going to be 0. So for loop 2 we will write 2 I1. We have I1 current in resistor 2. Now let's say these are the points A and B. So there is another approach to doing these questions wherein we can assume potential of point A, and then we find that potential of point B will be 0 and so on, and then we write currents. So there is another approach to this, but we have used KVL. So second loop, the equation is going to be minus 2 I1, okay, and minus 1 volt, that is E2. We are going from plus to minus, and again when we are coming back in the loop, we see that we are meeting current in the opposite direction, so that becomes a plus 5 into I minus I1. Once we open it, we arrive at 5i minus 7i1 is equal to 1, and the first equation we simplify and we arrive at 9i minus 5i1 is equal to 3. So we have two variables, I and I1, and we have two equations, so we can easily solve that. So what we'll do is we'll multiply first one with 7 and second equation with 5, and we'll nullify I1, and yeah. These are standard methods of solving equations in a loop, and the linear equations which you would have studied probably in your high school program, how to solve linear equations. So what we do is we work out one same coefficient for one of the variables, and then we either subtract or we add. So here we will subtract because the signs are same, and we get 38i is equal to 16. That is I is equal to 8 by 19 ampere. So that is one value we got, and once we put this value in any of the equations above, we will find value of I1. And obviously the third current through resistor R3 is I minus I1, so that we will get straight away. Now you would notice that we are getting all positive values for the current, and that means that the directions we assumed for these currents is perfect. So had the direction of the current been different, then we'll get a negative value for that current, and that simply says that that the direction we assumed was wrong. So the correct direction would be opposite of the direction we assumed, but here we are getting all positive values. I try to minimize calculations, and I keep bringing numbers up to the last point, because what happens is most of the numbers get adjusted. I mean the numerator with denominator or something. So we got 3 by 19 for I1. That means I minus I1 is going to be 8 minus 3, that is 5 by 19. So that means there is in resistor R3 there is a current in the direction we assumed. So we were right in terms of assuming directions for all the current. So now as you see that the battery E2 is actually not giving any current, it's in turn receiving current from the first E1. That means E2 is in the process of getting energy from E1. It's not providing any net current to the circuit. Now we have question A part, which says that what is the rate at which energy is dissipated. Now we know that the current in R1 is I, the full current, okay, that comes from E1. So energy dissipated, we know the formula, that is I square R. So it will be I square R1. Energy dissipated in R2 is going to be, where is R2? R2 is this 2 ohm. So it is going to be I1 square R2. Okay, we'll put the appropriate values. I haven't done the numbers, so you can put those numbers and find out the solution, which is 3 by 19 whole square into R2, which is 2 ohm. Now energy dissipated in R3 is going to be same way. We have I minus I1 current in R3, so it's going to be 5 by 19 whole square into R3. So that is the power dissipated in R1, R2, R3. Now next question is, what is the power of battery 1? Now you know power of battery or an EMF provider is E into I, or which is voltage into current. So power of battery 1 would be E1 into I, because that's the current that is flowing out of E1. And the last part is power dissipated by E2. Now that is going to be in negative. Reason being that E2 is not providing any power, it is in fact recipient of power. It's getting current from battery E1. Okay, so that's the question, and we will try to accommodate as many questions from this 10th edition of Resistor, which is a wonderful book for JEE preparations. And I'm going to handpick some right kind of questions and accommodate that in mains here. So please keep connected, please subscribe our channel and keep in touch. Thank you.